And at this time, I'm excited to introduce our next presenter. That is Mr. Roger Meng Yao. He's an enterprise solutions architect from Uila. Are you there, Roger?
Yeah, I'm here, David. How are you today?
I'm doing great. Thanks for being on the EcoCast today.
You're welcome. And actually, David, I want to share my screen. The first thing I want to check with you is whether you see my screen or not.
I do. You want to maximize your slides? There you go. I see now.
Mm-hmm. Looks good.
Looks great. Take it away.
Okay. So thank you, everybody, for joining this webinar. And I'm going to present Uila to you. First, I want to correct the pronunciation. We are Uila. It's a Hawaiian word, means lightning in the cloud. That's basically what we do. What we provide is full stack visibility into your data center that cover application to infrastructure. That's why we enable you to do the root cause very fast. And the company was founded in 2013, and we are based in Santa Clara, California. And in 2015, we had our product GA, and up to today, we have over 10,000 servers being monitored by Uila. We are so proud of that. And our founders are a few veterans from the networking industry. They have strong background in network performance, packet analysis, and Wi-Fi security. And now they apply their secret sauce into the data center monitoring domain and founded this new company. And there's a few major challenges faced by IT ops nowadays. The first one is always troubleshooting, right? It takes a long time. It always ends up with no conclusion. The second major challenge is, since your data center have so many visibility holes, in the market, there are so many monitoring solutions for you, right? Normally, you don't have enough budget to purchase all of them. And the third challenge is, even though you have the luxury to purchase a bunch of tools, but that doesn't necessarily mean you're in a better situation, because those tools are often siloed, right? That means you don't have a way to gain the comprehensive and correlated analytics into your system. And when your end user complain, the service stops running, and each team using their own tool to check their own domain and conclude there's no issue found, right? So what's the next step? They often end up with a lot of finger pointing. But the issue is still sitting there unresolved, right? And we believe by adding the application visibility on top of the virtualization layer and infrastructure layer, we can enable you to address these kind of challenges and make you in a better position or situation. Let me repeat what we do. Uila offers the application to infrastructure full stack visibility. That brings three key benefits to you. The first one is to shorten the troubleshooting process down to minutes and give you the root cause in a very fast way. And second major benefit is you gain a single pane, which cover end user experience, application performance, service availability, and even infrastructure health. That enable you to do planning, optimization, and prevent issue from happening. And as you may know, right nowadays, everybody is moving from private cloud to public cloud. And Uila is keeping up with that trend, which means the key benefits that I mentioned apply to the hybrid cloud environment. A little bit on what we do, a little bit on how we do it, our architecture slide. So as you can see, there's three components that Uila has. I would like to start from the first one sitting at the top. We call it Virtual Smart Tab. This is where the application and network intelligence coming from. VST basically is a small virtual appliance sitting on top of your vSwitch, sniffing the packet in and out of your virtual data center. And we turn on the deep packet inspection engine against all the traffic we sniffed. And that's why we can automatically identify over 4,000 applications. And for each application, we can track the application performance, we track the application dependencies, we give you the transaction level metadata. And the second component is the small square sitting in the middle. We call it VIC. So this is the component where the compute, storage, and even OS level information coming from. We rely on the API to query your cloud virtualization system for all kinds of analytics. And also VIC is the destination for the application and network metadata coming from VST. And eventually, all those metadata we collected converge on the third component that Uila has. We call it Uila Management System. Right? This is the place where the database engine is lying in, where the web server is lying. Component can be housed in our Uila SaaS cloud, or you can deploy it as another virtual appliance in your private data center as an on-prem solution. So after the architecture, I'm going to jump directly to my browser and to give you a quick live demo. Please allow me to switch to my browser. This is the dashboard. Whenever you log in your Uila Cloud, Uila portal, this is basically the first page you can see. As you can see, it's very colorful. In a nutshell, this is the single pane of glass view for you to monitor every aspect of your data center. What I mean by that is application, CPU, memory, storage, and network. First, I would like to focus on the timeline sitting at the top. Horizontally is time, right? We cover the latest 24 hours by default, but we allow you to go back to any time period you want to look into further. You can pick a time and day from the Dropbox at the top. And vertically, this timeline can be divided into 5 rows. From top down, it's application performance, CPU health, memory health, storage health, and network health. And in each row, we use color to indicate the data center's health status for that category or aspect. Green means good, red means bad. If you pay attention to the timeline, you may notice there's a small time slider, which you can move around and focus on the suspicious time period. Right now, everything looks green, right? Seems peaceful. But if you move the time slider to this time range, where you see a lot of red and orange, after I focused on that time range, there's 5 big color wheel below the timeline, where you see the big circle, right? They got refreshed to reflect the data center's health in each aspect. Respectively, it's application performance color wheel, network color wheel, CPU, memory, and storage, right? The purpose of the color wheel is to help you to identify or spot the hotspots, right, during this time period you selected on the timeline. Right now, from what I can see, the application performance color wheel is very hot, right? You can quickly spot the hotspots on the outer layer. After you mouse over to it, it's a VM. This VM is not doing well because the application health score is so low, application response time is so long, and more importantly, we let you know what type of service this VM is serving. Right? From the service list, this guy's serving HTTP, MySQL, and SSH. Unfortunately, my SQL server is not doing well. My SQL service is not doing well because it's color-coded as orange. The color coding is determined not only by the absolute value of the application response time, it also determined by based on the baselining we build up for you. We rely on the auto-moving baseline. Whenever we know your application response time deteriorate, we use color to draw your attention. After you know where's the hotspots, right? You want to do a deeper dive, and we'll provide you a set of analysis view for you to do deeper dive. If you pay attention to the menu on the left side, for each aspect, we have a analysis view. It covers application, network, CPU, memory, storage. Other than that, we give you we monitor your end user experience, plus we monitor your service 24/7. That's why we call ourselves full stack visibility. So the dashboard is really a single pane which covers almost everything in your data center. Since I'm focusing on application performance troubleshooting, I would like to pick application analysis to do a deeper dive. I'm going to go there, and the first screen I'm going to show you is called Dependent Service Map. And this graphics is automatically drawn by a Uila system, and we draw this dependent service map for this multi-tier application. A few key takeaways from this graphics. First, you know which VMs make up your application system. And who's the front tier, who's the second tier, who's the third tier. At a glance, you know that. And based on the arrow line, you know how they interact with each other. And more importantly, very quickly, you can spot where's the bottleneck in your multi-tier application. In this case, the bottleneck seems to be this guy, Oracle 11GN1, because it's a red ball, right? Mouse over to it. You know my SQL is suffering, and you want to do root cause analysis. Very simple. You just need one click on my SQL service. We lead you to the next view, which is root cause analysis view. In a nutshell, this is a place for you to correlate application degradation with infrastructure problems. If you focus on the two trending charts sitting at the top, the first one, which is the right, reflect application response time. We automatically select a 30 minutes time window where the red bar is red and so high, indicating the application response time slowed down. Plus, from the white bar chart, the transaction volume dropped a little bit by comparing to the previous 1 hour. For sure, your application slowed down, right? The end user is suffering. Then what's the root cause? In the middle, we use the small window to tell you CPU health is perfect, memory health is perfect, and don't worry about the dependent service and network performance. They are all green, and the correlation probability score is so low. What's the primary reason? The primary reason is storage health. The background color is red, plus the correlation score is so high. By reading the text, it has something to do with the long latency, right? You can click into the storage health panel to dive in deeper to get a detailed picture about the storage issue. But before I go there, I do want to highlight the worst transaction section sitting at the bottom. This is a place we'll offer you the transaction level visibility, including application response time, who's the client, which server it is, and what type of service it is. More importantly, from the request and reply column, what type of request the client is doing. This turned out to be very useful, especially when your application slowdown has nothing to do with infrastructure. All the small windows on the current screen will be green, right? So an infrastructure guy can capture this screenshot and share this screenshot with application colleagues, not only to defend infrastructure teams, but also to help the application team to look into the issue or narrow down the problem. That's how, root cause view can encourage this kind of collaboration between two teams. Now, let me circle back to storage health. And one click will lead me to the next layer, where we lay out the rewrite latency and rewrite IOPS across 3 tiers, including host kernel tier, which is the first tier, and with disk tier, and the deepest tier is the physical data store tier. And based on the background color of the small window, you'll quickly spot where's the bottleneck. In this case, the bottleneck is relatency across 3 tiers. Since physical data store tier is the deepest tier, I would like to start from here, right? One thing I notice is my latency is so high, but also the relatency correlate match very well with the read IOPS pattern, right? That lead me to believe it has something to do with storage contention. So what I would do next is to figure out which hosts are using my physical data store at this moment. What I need to do is to pick a bar on the host on the read IOPS trend. One click, the pop-up telling me this physical data store is used by a single host called host number 4, which happened to be the host sitting at the top tier. My next question is, which VM on this host are fighting for IOPS resources? Another click on the host level read IOPS. It's going to tell me there's a noisy neighbor who ranked the first on this list, right? My Oracle database server ranks second. So I know my noisy neighbor. The next question is, who suffered the most from the long latency issue? To figure out that, another click on the read latency. The breakdown telling me, even though my the noisy neighbors is using a lot of IOPS, but it's not suffering a lot, right? But my Oracle database server suffered the most from long latency. So at this point, this is a perfect example of the noisy neighbors, right? Your noisy neighbors occupy a lot of resource, and you are suffering a lot. So after knowing that, the system administrator can do something to remediate the situation, right? And the pressure on the application performance going to be released. Let me circle back to the dashboard. And my next screen is about networking analysis. So as you can see, everything is also time-driven. On the timeline, we are reflecting the bandwidth usage. It's very easy for you to pick the suspicious time period. For example, I'm going to focus on this huge spike. I would like to figure out which type of traffic, which type of entities are contributing to that huge spike. After I focused on this huge spike, the flow analysis view below it got refreshed. A quick interpretation on how to understanding this flow analysis view. From left to right is host, DV switch, port group, and VM. Right? In each column, we use the small bar to represent each entity. So the width of the bar is determined by the bandwidth usage, and the color of the bar is determined by the networking issues we identify for you. And the right column is called classifier. It means application protocols or traffic types we identify for you within the time period we selected. At a glance, you know what type of traffic you are having at this moment. And based on the length of the bar, you know which type of traffic contribute the most to the traffic spike. For example, in this case, I know iPerf contribute the most to the huge spike. By reading the information on the tooltip or following the ribbon, you quickly know where the traffic is coming from, right? From which VM, from which port group, from which DV switch, from which host. At a glance, you know all that. Other than that, we use color to draw your attention to the problematic VM from the networking perspective. For example, at this moment, I saw orange bar. I mouse over to it. It turned out to be a VM. So on the tooltip, we are tracking, a lot of networking issues, including long network response time, fatal retries, virtual packet jobs, zero windows, and reset. Right? Those are all kinds of networking issues that can happen in your virtual environment, but often, people ignore them. And in this case, we know the root cause right away. It's not because something else. It's because of a lot of virtual packet jobs happening on this VM. Okay. The next highlight is storage analysis. Again, on the timeline, we are reflecting the rewrite latency and rewrite IOPS of the whole data center. Very quickly, you can focus on this suspicious time period to see where's the bottleneck or where's the hotspot. So very quickly, from the graphics below, you know where's the bottleneck. From left to right, it's physical disk, data store, VM, and vdisk. Right? Again, in each layer, in each column, we use small bar to represent each entity. The width of the bar is determined by IOPS usage. The color of the bar is determined by rewrite latency. Since I see some red bar at the VM layer, I mouse over to one of them to let me know this VM is suffering the long latency. And instead of only telling you the rewrite IOPS and rewrite latency numbers, most importantly, we are weaving the application context for all the infrastructure analysis view. That's how we differentiate from other infrastructure performance monitoring solutions. By doing so, we enable you to do root cause analysis or evaluate the impact of the infrastructure issue. In this case, unfortunately, my SQL service is not doing well. Right? It's color-coded as orange. Seems like it's being impacted by the long rewrite latency. Right? To do root cause analysis or to evaluate the impact of the infrastructure issue, you just need another click on my SQL service. And we lead you back to root cause view again. Right? From here, you can do root cause analysis to see the detail of the storage issue. Basically, this is exact page. A couple. My live demo gonna end here, but I want to add a few slides coming from the real customer to show you how user using Uila to address their challenges in the real life. Please allow me to switch back to the slide. And this is a slide coming from a prestigious hospital. They have Exchange system, but before they install Uila, they have two major challenges. The first one is, after years of operation, the system administrator lost track of their Exchange system. Right? Nobody know, what kind of VM, make up this Exchange system. The second challenge is, every morning from 9 to 10, right, nobody know what's the root cause. So after I install our software for the POC, and I bring up the dependent service map for them, the first surprise they had is, very quickly, we review the complexity of the Exchange system. Take a look at the first picture sitting at the top. You notice there's so many VMs, so many servers got involved in the Exchange system. And this customer is happy. What makes them more happier is based on the comparison between the good hour and bad hour. They quickly notice the delta in between, which turned out to be a bunch of VM server who light up as orange or yellow in the second picture at the bottom. Right? After we click in each red ball or orange ball in the second picture, we quickly identify the bottleneck, which turned out to be the MySQL server, but somebody scheduled the backup process on the MySQL server. It's supposed to be during the nighttime, but somebody made a mistake and scheduled the backup process in the morning time. That impact all the Exchange server, which light up in the as orange ball in this picture as well. Next slide is from the larger and retailer in North America. The story starts from the flow analysis view. So after I installed the software for them, I was doing training at that time, right? And we came across Dropbox traffic at that moment. So the customer became alert because the Dropbox traffic is really against their data center policy. And after a deeper dive from the root cause view, which is the picture in the middle, we find out the pattern of the Dropbox transaction. It's very, very constant. It's even 24/7. And also from the worst transaction section, which is the picture at the bottom, we quickly identify which user are initiating those Dropbox traffics. It turned out to be a sales guy, right? So after collecting all this evidence, the system administrator feel very confident and comfortable to submit a ticket to the higher management, ask the sales guy to stop using the Dropbox. The last slide is from the largest retailer of Nike. It's based in Asia. So this company, has thousands of POS cash registers, but their pain point is during the peak hour, the register machine stopped ringing. Right, everything seems to slow down, and nobody knows what's the root cause. So when I bring up this flow analysis view for the storage, so very quickly we notice two things. The first thing is all the VMs or vDisk who are serving, they light up twice. And more interesting, you storage flow of the disk and they convert data and the red bar site. After knowing this, we quickly automatic data out of or data store. So we're remediate the situation. Everything happy. So for time purpose, I don't think I have time to go the next two slides. I'm going to stop here and say thank you to everybody. And one thing I would like to, if you are interested in Uila demo file, registration, and I'm going to be the guy to help you to install the software and give you the training or finding analysis. And thank you, everybody.
Excellent presentation. Thanks so much, Roger. Really cool user interface there. I like the different, use cases and examples from real companies. So a few questions from the audience here. First one, trying to clarify, Uila or software?
We are a purely company. All the software is run. Deploy our software. It's very, so we just need to deliver several VA files. The exact same UI today.
Excellent. So it captures from vCenter, is that true?
Part of the information is from vCenter API, right? For example, like all entities, the topology, plus the compute and storage metrics. But some of the networking and application metadata are coming from the VST, right? VST is sitting inside of your virtualized data center. We snip the packet, right? We rely on the technology called the packet inspection to get the, application and network intelligence.
Okay. And then what about, kind of time to show value? How long does it take?
You mean the free trial or the deployment?
Well, once it's deployed, how long before you start getting useful information back? Does it take a while? Does it take a few days? Or
normally we require a few days to build up the baseline. That's why the colors and the numbers make sense for you, right?
Got it.
Normally, one thing I want to add is normally after the deployment, right, we leave the data cook for a couple of days. Then we schedule a meeting with customer to go through the training and do finding analysis to help them to get up to speed.
Okay. And then how is it licensed?
We license based on the physical CPU socket. So for example, your hypervisor has 2 CPU sockets, right? And our license is based on that. Exactly the same model as VMware.
Okay. So no matter how many virtual machines you have, your license is
we don't
still
count.
based.
Correct.
Excellent, excellent. Well, thanks so much. Great demonstration today, Roger. I encourage everyone to go check out the free trial download that Roger's got up there on the screen. If you need that URL, just post it in the questions box, and I'll send it over to you. But thanks to you, Roger, and thanks to Uila for being on the event today.
Thank you, David.